In this video clip, we'll learn the database approach. Here are two main topics that we'll go over in the next few slides: the data hierarchy and database management systems. Data are stored in a hierarchy that begins with bits and proceeds all the way to database. A bit represents the smallest unit of data a computer can process. A bit can consist of a 0 or a 1. A byte has 8 bits, which can be used to store a letter, a number, and a symbol. A logical grouping of characters into a word, a small group of words, or an ID number is called a field. For example, a student's name in a university's computer file, or an employee's name in a company's computer file. A logical grouping of related fields is a record, such as the student's name, the courses taken by that student, and the student's grade. For example, in this sales transaction table, each row is a record. A record is a logical grouping of related fields, such as the sales transaction ID, salesperson's name, and the sales amount for that salesperson with the transaction ID. A logical grouping of records is called a data file or a table. For example, a logical grouping of sales transaction records is a sales transaction table. A logical grouping of related files constitutes a database. For example, a university's database may contain students' file, faculty file, course file, equipment file, and parking file. Using database approach can help us eliminate many data problems that we discussed in the previous video clip. Databases minimize three main problems. We'll go through each one of them in the next few slides. In the past, organizations have various types of applications, and each application is a computer program designed to perform a specific business function. So, each application in an organization had its own data file directly associated with. This causes all kinds of problems, which are addressed by the database approach. One of those problems is data redundancy, which are data stored in multiple locations. The second problem is data isolation, which means applications cannot access data associated with other applications. In the database approach, you'll store data one time in the database, and all applications can access it. The third problem is data inconsistency, which means various copies of the data do not agree with each other. For example, in one application, your address could be one thing, but you move to another application, your address might be different. So you have data inconsistency problem here. In the database approach, you just change your address in the database once, and all applications are using the same address. In addition, database systems maximize the following benefits. First, databases enhance data security. In the old application, we have different security constraints on different data files in each application. In the database approach, heavy security measures surround your corporate databases. Next, database increases data integrity, which means data meet certain constraints. For example, your GPA cannot be below 0 or above 4.0. So we need to set the constraint that the input of GPA should be numbers and within the range of 0 to 4. Third, databases ensure data independence, which means application and data are independent of each other. In this case, all applications can access all the data in the database. Next, let's take a look at the most commonly applied database management systems. Relational database systems. The relational database model is based on the concept of two-dimensional tables. Each table has rows and columns. Each row is a record, and each column is an attribute or field. An attribute is a descriptor or a characteristic of that record, and each cell has a value. Every record in the database must contain at least one field that uniquely identifies the record, so that it can be retrieved, updated, and sorted. This identifier field or attribute is called the primary key. For example, a customer record should use customer ID as the primary key, and a student record should use a unique student number as the primary key. In our university's case, the user ID can be used as the primary key because it is the number that can uniquely identify you. You may ask, why we cannot use student names as the primary key? This is because two students may have the same name. In this case, student names would not be the unique identifier. A foreign key is a field in one table that uniquely identifies a row of another table. It is used to establish and enforce a link between two tables. In this example, we have customer table, and customer ID is the primary key in the customer table. We also have order table, and the order number is the primary key in the order table, and customer ID is the foreign key in the order table, because it can uniquely identify a row of another table, which is customer table. In this way, customer ID establishes a link between customer table and the order table. In the next few slides, I will talk about data model and especially entity relationship or ER modeling. A data model is a diagram that represents the entities in the database and their relationships. Entity is a person, place, thing, or event about which information is maintained. An attribute is a particular characteristic or quality of a particular entity. Both primary key and foreign key are attributes of the entity. There are three types of relationship among the entities: one-to-one, one-to-many, and many-to-many. For example, in this ER diagram, we can see there are four entities: professor, class, student, and parking permit. The relationship between class and professor is one-to-many relationship, because a professor can have many classes and a class can have only one professor. The relationship between class and student is many-to-many because a class can have many students and a student can have many classes. The relationship between student and parking permit is 1-to-1 because a student can have only one parking permit and a parking permit can have only one student. Let's take a look at the attributes for each entity. Student entity has 3 attributes: student ID, student name, and student address. Student ID is the primary key. Parking permit entity also has 3 attributes: permit ID, student ID, and car type. Permit ID or number is the primary key, and student ID is the foreign key because it can uniquely identify a student in the student table. Student ID links parking permit table and student table together. Class entity has 4 attributes: class number, class name, class time, and class place. Class number is the primary key. Professor entity has 3 attributes: professor ID, professor name, and professor department. Professor ID is the primary key. Okay, here is a question. Please take a look at the employee table and the class table and fill in the blanks. Here is the answer. Employee ID is the primary key in the employee file because it can uniquely identify each record in this table. Employee ID is the foreign key in the class table because it can uniquely identify a record of the employee table. Okay, in the next video clip, we will talk about big data, data warehouse, and data marts, and knowledge management.